Well, I'm going to go through the three questions that most of you had issues with 3D Pythagoras and 3D trigonometry. So this is question 9 from the Pythagoras worksheet. So you're told you have a square-based pyramid has a perpendicular height of 15, which is given to you in the diagram. The apex of the pyramid is directly above the center of the square, and CE is 17, and that's also labeled, and we're looking for length AB. So we want the length of one side of this base. So to get started, we're going to need to work out which right angled triangles can we use. So I can see that I can draw a right angled triangle from O to C and from E to O. So that's triangle 1. And you can see there's a right angle there, and I have one length, which is 17. Actually, I have two lengths, it's 15. So I can now find length OC. So let's draw this out here, just a quick sketch. Got 17, 15, and we'll call this A. So A squared, and that's the hypotenuse, plus B squared equals 17 squared. Your B is 15, so A squared plus 15 squared equals 17 squared. So A is equal to the square root of 17 squared minus 15 squared. 17 squared minus 15 squared. You get 64, and then when you square root it, you get 8. Now, this is the important bit that some of you may not have got. So you can see OC is a length from the center of the square to one of the vertices. Well, we can actually also draw another right angle triangle. If we call this point M, which is the midpoint of BC, well, then you actually end up with a right angle triangle. And this length here is the same as that length there. So looking at that triangle from above, you end up with something like this. You know that this length is 8. Now, more importantly, you also know that this length is something, well, we'll call it X, and we can call this length X as well, because those two lengths match. You can then just use Pythagoras again. So x squared plus x squared equals 8 squared. 2x squared equals 64. X squared equals 32. X equals root 32. Now, this is the length x that we found here. So that's root 32. So all we have to do to find length AB, well, AB is the same length as BC, so we're just going to double x. So root 30, so 2 root 32, and then that will simplify into, so 2 root 32, you should get 8 root 2, which is 11.3. So that is question 9. You're not told how to give your answer, so I'm just going to leave it as a third. But in the worksheet, you have the answers there. So 8 root 2 would be a good answer in an exam. That's question 1. The second question I'm going to do is from the trigonometry worksheet. It's fairly similar to the first one if you get the idea from the first one. So we have a square-based pyramid. O is the center, E is above O, M is the midpoint of AB, and then the other two lengths are labeled. Work out angle EMO. Well, if you get the previous question, it's going to be practically the same thing, except for the second bit, we're using trigonometry rather than Pythagoras. So this is the triangle that we're looking at here, EMO. So we know that that triangle, if we just draw this out here, we can say that this is 12. We don't have any other information for this one so far. We don't know this length here. That's not going to be 15. So we're going to have to find another triangle that we can work out, and in this case OC, EC and EO. So that triangle there, I'll use a lighter color so you can see it, is going to be 12, 15, and then this is just OC, which we don't know, we're going to work out. So we can use Pythagoras to work out that length. So that length will be, let's call this A squared plus 12 squared equals 15 squared. So A is equal to the square root of 15 squared minus 12 squared. So it's 225 minus 144. You get 81. Root 81 is 9. So A is 9. Now, if we know that this length is 9, just like the previous question, we can say that if we're looking at that from above, that's the length is 9. This triangle we get here is a right angle triangle. So again, we're just going to call this X. We're going to call this X. So we're going to work out what X is. Once we have that X length, that length is going to be the same as OM. So we can say 2x squared. Let's write this out carefully. So x squared plus x squared equals 9 squared. 2x squared equals 81. So x is equal to 81 over 2 all square rooted. So let's just 81 divided by 2 square root. So I'm just going to leave it as, this for now. Now, if we know that that's our length of x, well, we can now apply that length to MO because that is that length there. So root 81 over 2. And then you just use Pythagoras trigonometry. So you have opposite. We're not interested in the hypotenuse, but we just label it. And then this is the adjacent. So to find the angle here, sorry, this is a bit messy. We can use opposite and adjacent. So that is going to be tan. So tan theta equals opposite, which is 12, over adjacent, which is in brackets root 81 over 2. On the calculator, I'm going to do that. So fraction 12 over, and then a fraction inside a fraction is going to be square root . So square root of 81 over 2. And then shift tan inverse of the answer. And then you get 62 degrees. Okay.